All right, we're going to take a look at recursive sequences. All right, first vocabulary first word is recursion. It's the process of choosing a starting term and repeatedly applying the same process to each term to arrive at the following term. Recursion requires that you know the value of the term immediately before the term you are trying to find. So in order to find the third term, we'll have to know the term before it. We'll have to know that second term. Now, what we've taken a look at the past 2 days have been explicit formulas, meaning you don't have to know the terms before it to find the 10th term or the 100th term. That's the nice thing about explicit sequence formulas. You don't have to know the terms before it. Sometimes it's helpful. And with recursion, we'll have to know the terms before it. There are a few things. It has 2 parts. A recursive formula has always a starting value for a sub 1, so it always has that first term. You'll be given that first term because, as I mentioned, you have to have that backup, that buildup to know the sequential terms. And the recursion equation for a sub n is a function of a sub n minus 1. So that means the term before it. Now also, the recursion formula may list the 2 or more terms of starting value. So you may have a sub 1, a sub 2, depending on the nature of the sequence. So when y'all took a look at the Fibonacci sequence, you're given that first term is 1 and the second term is 1. And then you're able to build a sequence based off of that. So depending on the sequence, you may need 1 or more terms. In such cases, a sub n portion of the formula is dependent on the previous 2 or more terms. And we'll be taking a look at more sequences like the Fibonacci as well. All right, the first thing we are going to do is we're going to write the first 4 terms of the sequence. Now, as I mentioned, it's recursive, so we're given that first term. So we know the first term is -4. Now to find the second term, we're substituting into the value. So we have a sub 2 equals a sub 2 minus 1 plus 5, which equals a sub 1 minus 2 is 1 plus 5. Now here we have to know what the first term is. We're given what that first term is. So we're going to substitute a -4 in for a sub 1. So our second term, a sub 2, equals -4 plus 5, so it equals 1. Now to find the third term, we do the same thing. So we have a sub 3 equals a sub 3 minus 1 plus 5, so that equals a sub 2 plus 5. So to find that third term, we have to know what the second term is, which we just found to be 1. So we substitute 1 in for a sub 2 plus 5, so a sub 3 equals 6. And to find the fourth term, we'll substitute 4 in for n. So a sub 4 equals a sub 4 minus 1 plus 5, which equals a sub 3 plus 5. So we need to know what our third term is, which we just found to be 6 plus 5. So our fourth term is 11. Now here we have an arithmetic sequence, and for these sequences, once you notice the pattern, so here we're adding 5 each time, you can continue that way as well. But if we were asked to find the 16th term, we would have to know what the 15th term is. So we'd have to keep on substituting in until we got to the 15th term of this particular sequence. All right. Our next example, we are looking at writing the explicit and recursive formula for the sequence. So we're given the sequence 2, 4, 6, 8, 10. So the explicit formula is what we've been looking at before. So that explicit formula here, I notice I have a common difference of 2 because it's arithmetic. So I can write this as a sub n equals the first term 2 plus n minus 1 times 2, which equals 2 plus 2n minus 2, and I distribute out that 2. So my formula, explicit formula, those cancel out, is 2n. Now the recursive formula, as we looked at the third slide, has 2 parts. It's given the first term. Now we know what a sub 1 is, and that is 2. It's that first term. Now to get a sub n, it's going to be built off that first term. So if we notice, we're adding 2 each time. So whatever the term before the term we're looking for is, we're going to add 2 to it. So the term before a sub n will be a sub n minus 1, and then we're going to add 2 to it, since we're adding 2 each time. So a lot of those patterns that we describe, it's going to come out more in the recursive formula part. All right, the next one we're going to take a look at is 3, 9, 27, 81. Now, here we can take a look at the explicit formula first. Here we have a common ratio of 9 over 3, 27 over 9, 81 over 27. Our common ratio is always 3 over 1. So our common ratio is always 3 over 1, so it's a geometric. So we can use the formula a sub n equals our first term, 3, times our common ratio, which is 3 over 1. But we can write it as 3 to the power of n minus 1. So that's our explicit formula. Now, recursive formula, keep in mind, always has that first term. Our first term is 3, and now we need to find what a sub n is. Now, if we notice, to get to each sequential term, we times the previous term by 3. So this formula will be 3 times the previous term, which we write as a sub n minus 1. All right, hope you have a great evening, and I will see you tomorrow.